Hi, this is going to be a quick little video in which we talk about pressure systems, like the big H's and the big L's you see on the weather map when you're watching the 5 o'clock news. To get all this stuff, we got to go back and we kind of got to look at three different things that we've already learned in the weather and the climate unit. We've got to talk about air masses, we've got to talk about air pressure, and we've got to talk about the Coriolis effect. First and foremost, any pressure system it's an air mass. So where you see the H, it's an air mass. It's the center of an air mass. And when you see the L, it's the center of an air mass. Now, high pressure means high density air. Cool air is dense, and dry air is dense. So a high pressure system is cool and or dry. And low density air is warm and or wet. So a low pressure system is warm and or wet. The most high pressure is going to be continental polar or an Arctic air mass because it's cool and dry. And the most low pressure is going to be a maritime tropical air mass because it's warm and it's wet. Now let's go back a little bit. Periodically in earth science class I'll bring this up. It's a rhyme. All things flow from blank to blank. Did you say high to low? Because that's good. You should have said high to low. And when we talk about pressure systems, we're talking about air flowing from high density air to low density air. So when you see that big blue H on the weather map, that means that the air all around it is moving outward away from the center of the low. Now the other day in class, we talked about a Foucault pendulum and we talked about Coriolis effect. And if you recall, what we learned was everything in the northern hemisphere gets turned to the right because of the Coriolis effect. So when the air comes out of a high pressure system, it's going to come outward and it's going to turn to the right, which gives it an outward and clockwise rotation of the air around a high pressure system in the northern hemisphere. You should draw this diagram on your paper where it says top view. You can pause it. I'm going to continue. Now, you can't just take a whole bunch of air and move it away from a central point in the atmosphere and not have it fill in from somewhere else. So what's happening is you have downward moving air. That air is cool, that air is dense, and so it's actually sinking, which is what's generating the outward moving air. So from a side view, and you're also drawing this diagram, so again, if you need to pause it and draw the diagram, you have downward moving air, which then spreads outward and clockwise away from a high pressure system. We'll talk more about that downward moving air after we talk about lows. So as I said previously, a low pressure system is warm and or moist air mass. The low density makes it low pressure. And so you have air moving from all around it inward toward that central point. Because of the Coriolis effect, the air around a low moves inward and counterclockwise. Now, if the air is moving inward toward a central point, where does that air go once it gets there? Well, it goes upward. And again, in reality, it's the upward moving air that's pulling the air inward. Now, when we talked about water in the atmosphere, and when we talked about climate and mountains, whenever air is moving upward, especially warm, moist air, it moves upward. The air around it is lower pressure, higher up in the atmosphere, so it expands. And because it expands, it's cooling, and it may eventually reach the dew point, which creates clouds. Now, I said I would come back to this. In a high pressure system, the air is moving downward. In a low pressure system, the air is moving upward. That upward moving air around a low, or above a low, generates clouds and precipitation. Conversely, in a high pressure, the downward moving air prevents, not only does it not create clouds, but it prevents clouds from forming. So a high pressure system tends to have fair weather. Now if we look at this overall weather map, this was from a few years ago, but if we look at the weather map, you'll see where the blue H's are. It's generally dry and clear. The only exception is that one over Oklahoma. Sorry, got ahead of myself there. And where you see the lows, you generally see some precipitation. Now again, this is a computer generated map, so the lows and the highs, it tends to plop them all over the place. There aren't really that many. But you can see the low over New York State's generally generating precipitation. The low over Kentucky, Tennessee, North Carolina is generating precipitation. The low over North Florida is precipitation. And then that low over Mexico is actually a temperature-driven low, so there's not necessarily precipitation with that. So that's it in a nutshell. If you have any questions, I want you to write them down on the side of your paper, and we'll spend a few minutes in the next class going over this. Otherwise, I'll see you in class next time. Thanks.